So we're going to talk about classifying chemical reactions because, as it says at the top of your note sheet that you got in class, you can't predict products, which is what we're going to move on to for the last couple days here of the semester. You can't predict products without understanding what kind of reaction you're looking at. So the first type is combustion. Combustion just means burning, and really it means anything added to oxygen that gives off a lot of heat. As you can see there, these reactions are very exothermic, meaning they give off a lot of heat. But we're going to focus on just when a hydrocarbon, which means carbon and hydrogen specifically, but sometimes also oxygen, in a molecule is one reactant, and the other reactant is oxygen. And so that's what you see there, the O2 on the left side of the equation. Remember that oxygen is one of our diatomic or Brinkelhoff molecules. So these are really easy to predict because every single time you get carbon dioxide and you get water. So predicting the products is really easy as soon as you recognize that it's combustion. And then it becomes a matter of balancing, which sometimes is difficult. So let's see an example here. If I have a hydrocarbon like, let's say, CH4, I'm going to know it's combustion if it's being added to oxygen. And but again, the easy thing here is every single time, no matter what the hydrocarbon is, we get the same two products. We get carbon dioxide and we get water. And so we just need a balance, right? So we have, looks like, we always want to save oxygen for last on these because it's by itself. And so when I put a coefficient in front of oxygen, it doesn't change any of the other elements like carbon and hydrogen. So probably just have to balance hydrogen, it looks like in this one. So I'm going to put a 2 in front of water, and that's going to give me 2 times 2 is 4 hydrogens, and that matches my 4 hydrogens on the left. It does also give me, it changes my number of oxygens. So you can see on the right side, I have 2 here plus 2 times 1 is another 2, so I have 4 oxygens, right? 4 O's, okay? So on the right, I only have 2. I just have the subscript 2. So just like we worked on balancing before, the only thing we can do to change the number of oxygens is to add a coefficient. So 2 times what would give me 4 on the left? And of course, the answer is going to be 2, right? So I'll get rid of all the rest of this mess, and most of the rest of it, and there's my balanced equation. Okay? Let's try another one. Let's say this time we have one that has, let's see, this is ethanol. So it has oxygen in the compound as well as being burned, so we're adding oxygen to it. We're still going to get CO2 and H2O. Anytime we have just carbon, hydrogen, and oxygen as our reactants, so carbon, I've got 6 hydrogens and I've got 3 oxygens. Anytime those are my only reactants, it's going to be combustion, and we're going to get CO2 plus H2O. So again, balance oxygen last. So balance, let's say, carbon first maybe, and I have a 2 on the left, so I'm going to put a 2 there on the right as a coefficient. Remember, we never change subscripts. I can't put a 2 after the C. I can only say that I have 2 carbon dioxide molecules. If I put a 2 after the C, that actually changes what the molecule is. All we can change is how many of those molecules you have. So I put a 2 in front of the CO2. And then on the left, I have to be careful here. I've got 6 hydrogens because I have 5 here, and I have 1 over here by itself. So if I have 6 hydrogens on the left, what am I going to put in front of water on the right? I'm going to put 3. Okay. Okay, so this gives me 2 times 2 is 4 oxygens there, plus 3 times 1 is another 3 there. So 4 plus 3 is 7. Now over on the left, it looks a little funky because 2, I would have to multiply by 3.5 to get 2 to equal 7. But I don't actually have to do that because I've got this lone oxygen over here by itself. So I can actually just multiply my O2 by 3. That gives me 6 oxygens there, plus a 7th there, and it's balanced.